Palindrome. Implement a function to check if a linked list is a palindrome. I have half a mind to skip this because we literally implemented this as...
I swear we did a palindrome already, didn't we? Nope. Oh yeah, we did. 1.4. Given a string, write a function to check if it is a permutation of a palindrome. Given a string, write a function to check if it is a permutation of a palindrome. So, I mean, logically, if we have a function that lets us check if something is a permutation of a palindrome, then we also have something that can check for a palindrome, right? Well, yeah, but a palindrome is more specific than is a permutation of a palindrome. So I guess we just need to kind of copy it again, you know. So one kind of cool way, if you really had a linked list like the kind they have. Well, no, you can't run it backwards because this is not a doubly linked list. But I guess would be. Oh, what's this little plus minus thing right here? Oh, I actually wrote it. Okay. All right. Okay. So let's write it out. All right, chapter 2, problem 6, palindrome. I think this will be the last one. I'm gonna break for dinner after this. Hopefully I'll finish the other 2 tonight. All right, that's CLJ. Cool. Yep. All right, cool. And so take this out. Yeah. So now we're on LS again. And is this a palindrome? Yes, it is. Is this a palindrome? Well, first of all, there's only 2. There's an input and an output. Is this a palindrome? Yes. Is... Oh, wait, it's just trying to Boolean, isn't it? I'm kind of done. Okay, here you go. Yes. 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 No. What else do we want to say? Anything else that's interesting here? Yes. Oops. Let's say yes. What else? Yeah, I don't care. All right. So let's figure out if this is a palindrome. It's a palindrome if from the midpoint. All right, so I think it's pretty easy actually. All right, so we need to calculate the midpoint first. You know, they'd like us to use the 2-pointer solution, which is goofy. No, maybe it's not actually. Actually, I thought that was pretty cool, to be honest. But if we take the count of LS, we can calculate the midpoint. Start naming things a little bit better.
C. Okay, LS count. I think we want quotient too, right? Oh yeah, duh. Let's do we need a palindrome that is an even length. And what else do we need? Let's do an odd. Okay, wonderful. And okay, Alright, so if we can get the midpoint, let's just check what quotient does, because that confuses me too half the time. Quotient of dividing numerator by denominator. Value of mn rounded towards 0 to the nearest integer. Okay. So quotient of 2, I think, is the midpoint, maybe. Rounds down, so for evens, the quotient of 2 is 2. 0, 1, 2. That's actually not really the midpoint. There is no midpoint for an even. But the quotient of 5 is also 2, and that is the midpoint at 2. Okay, I got an idea. Let's take a count first. Count of LS, right? And from that, let's take the midpoint, and let's just make it conditional such that if even C, then we want, what is the midpoint? Oh, wait a minute, actually maybe that is fine. Maybe we don't really care. It's not really the midpoint. What do I call the thing that you take? I'm just gonna say n for now. But n is just equal to c, right? Oh wait, I meant the quotient of c on 2. That's n. Okay. So basically, I'm gonna split at split at 2. That means I'm going to take 2, and then I'm going to... okay. I'm going to drop 2 and take the rest. But one of these might be too long if we are... Anyway, let's deal with that in a second. Split at 2 on LS. Alright, now we split it in 2. The issue is if we're odd, we need to also drop 1 on DS. So I'm going to immediately modify DS to say if odd length, we need to drop 1 on DS. Otherwise, you can just take DS. Alright, now I got the 2 split properly. And then basically asking the question, is TS equal to the reverse of DS? Right. I guess we could make this into a question. Palindrome. Just takes a string. Yeah, I'm getting hungry. Number of args doesn't match blahs. I screwed up somehow. Palindrome LS. Taken, I see. taking 2. Oh man. Why can't you write perfect code the first time? True palindrome, blah blah blah. Don't know how to create iSeek from closure claim. From closure core drop. If odd C, drop DS. You don't need to take an iSeek from that. Oh, you're saying you can't take an iSeek from DS, it sounds like. That seems unlikely. Oh, wait. It's not dropping it here, it's just... No, actually, it's not a terrible idea. Why isn't it the case that you drop is like this, but if you want to drop a certain number, you do that? Well, default drop would just be 1. But actually, yeah, I'm at rest, not drop there. Doesn't change the fact that everything's wrong, but, is this a palindrome? Oh, it's a good point. Not a palindrome. Wait, it is a palindrome, because we should drop the center one, right? 0. And we should then be saying the nil is equal to the nil, right? No, that doesn't make sense, because we... Count LS. Count LS. Quotient C. A little bit. What's going on? 1, 0, 1. True is not equal to false. Okay. You're all wrong. I feel like it would help to know what TS and DS were. So TS is 0, 0, which is very odd. Where the hell did you get 0, 0? I passed you 0. How do you have 2 zeros? This guy has 0, 1. What? Where are you getting the 1 from? Get out of here. Okay, C and N. C has got to be working correctly. That should return 1, right? Oh, wait, maybe I'm looking at the previous one. Yeah. Okay. TS is 0. DS is empty. Okay, I disagree with that, but I get what's going on. We want to slice something out, so I split at 2. Oh, why did I hardcode 2 there? That's not what I wanted to do. Oh, there we go. Let's try to think of some more falsy ones. It doesn't really matter what the values are, right? Yeah, okay, what else? I don't know. Alright, well. Anyway, that's a no. I will try to finish the rest of these tonight. Why do I keep doing that? Because I'm used to playing on Max. Okay.
Alt W. All right. Whoa. Yes. Back me up. Okay. I just need to copy this thing.